Good day, ma'am. My name is BLESSY ATIS Ilajas from BSEE 1A, and today I'm going to explain my output on how I derive my answers. So since these problem sets are kanang given na bitaw, so ang ako lang is kung unsa akong nasabtan and to explain kung giunsa siya based lang sa akong pagsabot. So the topic in the lecture 2 is waves. Problem set number 1, example 6.1 on page 794. Wave on a string. A student takes a 30-meter long string and attaches one end to the wall in the physics lab. The student then holds the free end of the rope. Keeping the tension constant in the rope, the student then begins to send waves down the string by moving the end of the string up and down with a frequency of 2 Hz. The maximum displacement of the end of the string is 20 cm. The first wave hits the lab wall 6 seconds after it was created. A. What is the speed of the wave? B. What is the period of the wave? And letter C. What is the wavelength of the wave? So as you can see from this problem set, these are the given. So the distance traveled from the by the wave, so it equals 30-meter long. The time, which is 6 seconds, and the frequency, which is equals to 2 Hz. So ngano na ako ano siya 2 seconds raised to the negative 1 kay where ang kuan mal is ay kanang where ang 1 Hz is equivalent to 1 second raised to the negative 1 power. So since 2 man na siya, so 2 seconds raised to the negative 1 power. Excuse me. So solution. So what is the speed of the wave? So letter A, the first wave traveled 30 meter in 6 seconds. So to find the speed of the wave, we must divide the meter over seconds. So ang atong distance is 30 meter, and then ang atong time, which is 6 seconds. So calculate 30 divide 6, which is 5. So therefore the speed of the wave is equals to 5 meter per second. So let's proceed to letter B. What is the period of the wave? So the period is equal to the inverse of the frequency. So time, which is equals to 1 over the frequency. So given naman atong frequency, so ato lang siya substitute. So 1 divided by 2.00 second raised to the negative 1 power. So calculate pa jud. Sorry. So 1 divide 2, so which is 0.5 seconds. So ang atong period of the wave is 0.50 seconds. So letter C, the wavelength is equal to the velocity times the period. So what is the wavelength of the wave? So to find the wavelength of the wave, so we must use this formula. So ang distance of the wave is times the period of the wave. So since napangita na mato ang kuan kanang speed of the wave, which is kani, so ato lang siya i-substitute na lang atong kuan na yun, period of the wave period of the wave is 0.50 seconds. So 5 times 0.50, which is equals to 2.5 5 or 2.50. So the wavelength is equals to 2.50 meter. So let's proceed to the problem set number 2, example 16.2 on page 794 to 795. Characteristics of a wave. A transverse mechanical wave propagates in the positive x-axis through a spring as shown in figure 16.4a. With the constant wave and the medium oscillates between positive amplitude and negative amplitude around an equilibrium. The graph in the 16.6 shows the height of the spring y versus the position x, where the x-axis points in the direction of propagation. The figure shows the height of the wave versus the x position at at t, which is time is equals to 0.00 seconds as a dotted line, and the wave at time equals 3 seconds as a solid line. A. Determine the wavelength and amplitude of the wave. B. Find the propagation velocity of the wave. And letter C. Calculate the period and frequency of the wave. So as we can see from the problem set, these are the given. So the dotted line in which it is equivalent to 0 second, and the solid line which is equivalent to 3 seconds. So solution, determine the wavelength and amplitude of the wave. So as you can see here in this figure, so we can see that this is the wavelength, no? So ang wavelength is kung saang, so from the word length, so ang katason sa wave, so wavelength, that's what we call wavelength. So then naman siya ang katason sa wavelength. So from this dotted line kani siya kana, so ang katason dire sa pinakataas, then dire dayon ang kaniden distance traveled, so from this to this, sa kanang like kuan bitaw siya kani siya ana. Then ana dayon ang dotted line. So as ako giingon ganina is ang dotted line is equivalent to 0 second, and then ang solid line which is kani siya kana solid line which is 3 second. Excuse me. Then ang amplitude dayon is kanang ang kuan bitaw niya, ang size niya sugod sa kaning sa 0 bitaw, like karang kung imo naon ang kanang is kanang ang like ang spring, so from the starting point, then ang kanang unsa bitaw niya ang katason, so mo na siya ang amplitude. So from 0 na siya ana katason. Dayon excuse me. Dayon therefore the wavelength is 8 cm. So kani siya bantog 8 cm ni siya, kay so kani 1 2 3 4 5 6 7 8, so 8 cm. Dayon ang amplitude niya is 6 cm po siya, kay so from 0 so ni 2 4 6, so ana siya kani ana siya, so mo na siya morang 6 cm ang amplitude. So ana siya. So letter B. So the distance the wave traveled from time 0 seconds to time 3 seconds, 0 second to time 3 seconds can be seen in the graph. So consider the red arrow. So kani siya from the red arrow which is show the distance the crest has moved in 3 seconds. So kung siya red arrow, so ana siya ana sa 3 seconds. Dayon the distance is 8 cm minus minus 2 cm which is 6 cm. So the velocity which is the delta x over delta t. So as ako giingon ganina is kanang 8 cm minus sorry 8 cm minus 2 cm. So para makuan ang para makuan bitaw niya ang ka ang distance niya, then divide dayon sa kanang sa time, which is 3 seconds minus 0. So 6 divided by 0, which is 2 centimeter per second. So muna siya ang propagation velocity of the wave. So next, we must calculate the period and frequency of the wave. So the period t, which is wavelength over velocity. So since ang atong wavelength sa ako ingon ganina is 8 centimeter dayon ang velocity, which is kani ato bago pa nato nakita nakuha, so 2 centimeter per second. So para since ang gipangita sa kuan is kanang period, pangitaon ay i-calculate na to ang period, so we must kanang cancel ang centimeter, so dayon 8 divided by 2, which is 4 seconds. So muna siya ang period of the wave. Dayon ang frequency dayon, which is frequency over 1 over t. So 1 over, so atong t, which is 4 seconds. So diba kayo mo nakuha naman to ang period of time. So 4 seconds, in which 1 divided by 4, in which 0.25 hertz. So muna siya. So therefore muna siya ang frequency. Ang frequency niya is 0.25 hertz, and ang period of the wave, which is 4 seconds. So that would be all. Thank you.